everyone, and welcome to Open Source Summit Japan Automotive Linux Summit. I am Noriaki Fukuyas, Vice President of Japan Operation at the Linux Foundation, and we are really excited to be here with you virtually. Before we get started, I would like to thank all of our sponsors, with a special thank you to our Diamond sponsors and event co-host, AGL, Automotive Grade Linux. And to our platinum sponsors, Cloud Native Computing Foundation and Fujitsu. Also, a quick reminder about our event code of conduct. Though we are virtual, everyone will have numerous opportunities to collaborate and engage with other attendees throughout the event. So please ensure you have read and abide by our code of conduct, which states that all attendees should feel safe, welcome, and included at the event. If anyone has any issues with or witnesses anything during the event that violates our code of conduct, please message our event staff right away. With that, it is my pleasure to first introduce Jim Zemlin, Executive Director of the Linux Foundation. We do not need much explanation about Jim, but just briefly, as Executive Director, he uses the experience to accelerate innovation in technology through the use of open source and Linux. Today, he will be providing an update on the Linux Foundation's activities and incredible year for open source around the globe in 2021. So please welcome Jim Zemlin.
Thank you, Nori. 日本へ行くのは大変お久しぶりです。And I really miss all of you and hope to see you again in person just as soon as the borders between Japan and the United States open up again. You know, despite being so distant, this has been an incredible year for open source around the globe. This year, as we celebrate the 30th anniversary of Linux, it's amazing to think that after 30 years from a hobby project in Linus Torvalds' dorm room in Helsinki, Finland, that Linux now powers the vast majority of the world's computing systems. It's the number one market share in enterprise computing, embedded systems, real-time operating systems. It represents 100% of the world's fastest supercomputers, many of which are produced here in Japan. It powers all major cloud computing platforms. It runs stock markets around the world. It's the vast majority of mobile handsets. Safe to say, Linux is the single most successful open source project in the history of computing. But at the Linux Foundation, we're not just about Linux. We host over 750 of the most important shared technology assets in the world. You know, today, any modern technology product or service is made up of 80 to 90% open source code. And at the Linux Foundation, our projects are a big part of that. Our Kubernetes project and the Cloud Native Computing Foundation are fundamental building blocks of modern cloud applications, powering telecommunications, enterprise computing, and edge computing workloads all over the world. You know, cloud native technologies like Kubernetes and the 100 other projects at the Cloud Native Computing Foundation have redefined the way developers build, manage, and deploy cloud infrastructure. But it's not just Kubernetes or Linux. At the Linux Foundation, we're also home to Hyperledger, the world's #1 permission blockchain. Hyperledger and its family of projects are being used in the financial services sector, supply chain management, and for modern central digital currencies all over the world. It is the #1 market share in enterprise blockchain and continues to grow around the world. Our Node.js project is the world's largest application framework. Our automotive-grade Linux initiative powers millions of production automobiles, many made by Japanese automakers such as Toyota. Our Let's Encrypt project is the world's largest certificate authority, issuing billions of TLS certificates, helping us all stay more private and secure. Our Yocto project is the world's market share leader in embedded systems and was even used to power the Mars rover helicopter to explore new planets. Our Zephyr project is the world's fastest growing real-time operating system. Our open network automation platform is the de facto standard for powering telecommunication systems that billions of users depend on every day. And our RISC-V initiative is a new breed of open hardware efforts that is the fastest growing silicon architecture in the world. We're super proud at the Linux Foundation to see the impact of the many, many projects that we host here. And the Linux Foundation itself is also growing and doing very well during the pandemic, despite the terrible headwinds that all of the uncertainty of COVID-19 has thrown at us. In 2021, we're adding a new member every single day. We trained over 2 million developers. We've updated our curriculum with over 30 new open source courses, 40 major updates, and have issued over 50,000 certificates proving that developers have the skills they say they have. In our virtual events around the world, we've gathered over 90,000 attendees with 3,000 speakers from 15,000 organizations and 192 countries. We launched new projects in new industries, including agriculture, gaming, healthcare, and insurance. Just a few weeks ago, we launched an important new initiative in cybersecurity, the Open Source Security Foundation, raising over $10 million to help improve the security of the world's technology supply chains. You know, as open source becomes so critical to the world's technology products and services, making sure that that open source software is secure and trusted is incredibly important. And I'm really proud to see industry leaders from around the world stepping up and helping out in the Open Source Security Foundation to help collectively secure the world's open source supply chain. You know, at the Linux Foundation, one of the things that we think is really important is making sure that open source are also backed by global standards. Our organization has now grown into one of the world's leading standards development organizations with over 130 standards, including the SPDX Software Bill of Materials effort and our Open Chain effort in order to work with organizations to help make sure that open source flows seamlessly across the global supply chain. Both of these standards became internationally recognized ISO standards this year. At the Linux Foundation, we're really happy to work with Japanese organizations, whether it's in open hardware like RISC-V, open source software like the many projects I described today, or on open standards like Open Chain. We offer a pantheon of ways to collectively innovate with your peers across the globe. I really wish that I could be there with all of you today, but I want to leave you with a single message. Despite the fact that we seem so distant, open source continues to be proof that all of us together are stronger than any one of us. And even when we have rivalries, whether they're corporate competition, or international rivalries. Open source is the one area where, as a freely available public good, we can all work together to create better innovation outcomes and help all of us both compete and cooperate at the same time. I want to wish you all the best going into 2022, and I hope to see you all again in person very soon. Thank you.
Thank you, Jim, for the update and for sharing exciting things that are happening at the LF. So next up, we have Dan Koshi, the Executive Director of Automotive Grade Linux and General Manager of Automotive at the Linux Foundation. Dan has over 22 years of experience spanning the automotive, telecom, networking, and mobile business verticals. He is responsible for the overall management and execution of the AGL collaborative project, an industry effort to build an open source automotive reference platform backed by leading car manufacturers around the world. Today, Dan will be talking about the AGL State of the Alliance and looking toward 2020 and beyond. So please welcome Dan Koshi.
Hello, everyone. My name is Dan Koshi. I'm the Executive Director for Automotive Grade Linux, and I'm here to kick off the Automotive Linux Summit and Open Source Summit 2021. So thanks, everyone, for joining us. Of course, we wish that this event had been in person. That was certainly our plan, but unfortunately, due to COVID and travel restrictions, we've had to hold this in a virtual event. But we have great content for you this week, and I hope everyone will find this very valuable. I'd like to start off by thanking all of our sponsors, specifically Automotive Grade Linux as the diamond sponsor, as well as CNCF and Fujitsu as platinum sponsors. In addition to all of our gold, silver, and bronze sponsors, we want to thank you very much. Without your generous support, this event would not be possible. And I'd also like to thank the AGL Advisory Board for their support and in their approval of sponsoring this event. Again, without their support, this event would not be possible. So thank you very much to all of the Advisory Board members. Okay, so I'd like to start off with a quick recap of the AGL activities in 2021 and some of the highlights that we've had during the year. We've had pretty strong membership growth given the challenges of COVID and the challenges that the automotive industry has suffered in terms of supply chain. And I'm sure you've all heard of the news of chip shortages and so on, but nonetheless, the automotive ecosystem in terms of AGL has been quite healthy. As you can see, we've added some very big and key members such as Nissan, Amazon AWS has joined at platinum level and is also now an AGL Advisory Board member. SoftBank joined at the beginning of the year. And notably, also recently, Red Hat just joined last week, I believe. So a very strong membership growth despite the COVID challenges. So we're really happy to see that. We also had during the year our very first AGL Tech Day. This was a reimagined virtual event, meaning instead of holding a full-blown AMM with multiple tracks, we decided let's have a curated set of speakers for specific topics and specific updates on AGL with a closing live Q&A. And so we thought this was a pretty good success. The attendance was good. The feedback was very positive. So for 2022, we actually intend to hold more of these. And I'm going to speak about that later when I discuss our future events. Notably during the year, we released UCB 11, codename Kukikoi. That was released in February. The release notes, as usual, can be found on our wiki. I have the link at the bottom here. And we also released Lucky Lamprey in July. So the point here that I'm making is that we continue, despite COVID and any kind of challenges, we've continued our clockwork, 2 releases per year, and none of that has been affected. And we plan to continue that pattern. Another update is we made major progress with the IVI expert group, specifically the AGL production ready profile. As you recall, we discussed this multiple times before. I think I mentioned it at the last Automotive Linux Summit. Toyota has contributed a lot of code from their actual production software base. And AGL, we've created this new production ready UCB profile. And our intention, of course, is to take the best of those production ready modules and start integrating them into UCB with the final goal of having a single UCB baseline that is as close to production ready as possible. And as part of that is contributions that Toyota has made around Flutter. And I'll talk about Flutter a little bit more later in the presentation. So let's talk about automotive software trends, for 2022 and beyond, and how AGL is addressing those trends, and how we're constantly evolving to produce software that is in line with where the industry is going. So one of the trends is that we have SoCs that are becoming very, very powerful and increasingly complex. And there seems to be a desire to start, software consolidation. What does that mean? It means that, companies are, OEMs are looking at consolidating multiple functions of the vehicle, potentially on a single SoC. So one of the things that AGL has been working on, and this is actually not new, we've been working on this for several years, is that we have a virtualization expert group. And one of the things in 2021 that was specifically where we specifically made a lot of progress is around VirtIO, which is being led by Panasonic. What this has done is that we're basically abstracting a lot of the IO to have the ability to run AGL either in a hypervisor environment or directly on an SoC, but without, by limiting the fragmentation that can occur in the software base by abstracting a lot of those hardware functions. And so this opens up the door to many potential real world applications, such as the consolidation of IVI and instrument cluster on a single SoC. In fact, we've been demonstrating that at AGL events and CES and other events for several years. So this is not vaporware, it's actually working. And yes, we're probably several years away from having this concept in an actual vehicle, but nonetheless, these types of things are being developed at AGL. And another great example is the ability to run Android side by side with AGL instrument cluster. This is another, what I would call classic use case where, for whatever reason, an OEM has decided to choose Android as an IVI solution, but would still like to use AGL for instrument cluster or maybe for heads-up display or other solutions. This allows them to do it. So again, AGL is well positioned for the evolution of cockpit consolidation. Another trend is of course, the growing software complexity. Automotive software features and the deployment complexity, meaning, the need for continuous updates, the need for continuous security patches is growing dramatically, obviously. And so AGL, what we've done in the past year is we've actually created a new expert group called Container and Service Mesh. And the goal is to simplify and standardize development of software in the vehicle, and I should say deployment of the software in the vehicle. What does that mean? Well, it's kind of bridging the gap between the embedded world, the classic embedded software world for vehicles, and the IT world by introducing um, a new generation of abstraction for the deployment of software. So by using containers and using traditional tools that have been used in the IT world, we will be able to really simplify the management and deployment and updates of software. And so that is, one of the really exciting things that are happening. And also by doing this, we open up the automotive software development world to a whole new generation of software developers that traditionally are not embedded software developers, but they may have significant expertise in deploying IT-based software. And as those two worlds combine, and I'm going to talk about that a bit later, those two worlds are kind of blurring right now. And so this is a great opportunity. And this new expert group, which is being led by Amazon AWS, is a great example of some of the exciting work that's going on in AGL. So as I mentioned, the lines are blurring between embedded IT and cloud. So that's another trend. And what I mean by this is, the vehicle is another endpoint in all of these systems, these IoT-based systems. And it's increasingly desirable to treat that like you would other endpoints. And so some of the things that, I like to characterize it like it's the abstraction and cloudification of the vehicle. Now, this is not happening overnight. No one is kidding themselves, but it is the trend and it is where we're moving. And so AGL already has 3 expert groups well positioned to work on this. And those are namely the vehicle to cloud expert group, the container and service mesh expert group, and the virtualization expert group. So those 3 entities combined and the stuff that they're working on is perfectly positioned for this blurring of embedded IT and cloud. And we really, with their expertise, we really plan to address these things in 2022 and moving forward. Another trend that you'll see in the headlines is that OEMs are building, quote, their own OS. And this is a bit of a misnomer in terms of when you hear this, these headlines, you'll hear that Volkswagen is building VW.OS or Daimler is building their own OS, or, they're not actually building their own OS, meaning a new operating system from scratch. In almost all cases, this actually means that they're using AGL and or Linux and or some of the best open source software components out there and building their own service delivery platforms. And they're branding that as an OS. Now, for us geeks and older folks that have been around, the term OS has always meant a low-level operating system. And so I think this term is now being overloaded a little bit. But in essence, all of these OEMs that are announcing these things are actually using, in most cases, in fact, in probably all the cases, are using Linux and AGL and open source components. And so AGL is perfectly positioned for this trend. I've mentioned this before in other talks. And the reason is that AGL is fully customizable. And you can use AGL as the starting point for these OS service platforms and change the UI, change the look and feel. The OEM can add their own applications, their own services, whatever they feel is necessary, and also can add their own branding. And so all of these value-added services can be built on top of AGL. And the key is that by using AGL as a starting point, we are eliminating the fragmentation in the industry by having everyone consolidate on a single set of software. And so that's something that AGL has always been advocating for and is well positioned for this trend. Another thing I wouldn't say is a trend, but I would say it's trendy, is that we're seeing a lot of talk about software-defined vehicles. I would even go as far as saying there's a lot of hype around this. Sure, software-defined vehicles is very analogous to software-defined networks and software-defined networking that we've seen in the networking world. So the term has been kind of adopted by the automotive industry. And all I have to say is I would say welcome to the party. AGL has been doing this for over 8 years. This is not new to us, although the term is now trendy. I actually have a chart on the right there, which is from, I believe, 2015, where we've always said that AGL is addressing all the major software functions in the vehicle. And we've always believed that the future vehicles will be defined by software. And as I've already mentioned, we're seeing the lines blurring between embedded software, IT, and cloud. And so to us, this is not anything new, but maybe to the press and the media and other organizations, that have started using the term. All I'd like to say is AGL is exactly doing that today and for the past several years. And I also like to add that we're working very closely with other organizations like Yocto, ELISA, CNCF, all under one roof at the Linux Foundation. So this really helps us be very close and nimble and react quickly to whatever software trends are happening. And so AGL is positioned for this, and I don't want people to be confused that software-defined networks is something new. It's essentially building software for vehicles and driving new functionality and new features, and that's what AGL has been doing. Okay, so I have other AGL updates. First of all, we have several expert groups that are very active with weekly calls, and normally we, without COVID, we'd be meeting in person also in various geographies. But for now, it's all virtual and Zoom calls. So my point here is that if you're a developer, we probably have something for you. And what I mean by that is, if you're an embedded developer, we're working on that. If you're a hardware person that wants to work on low-level stuff, we have a reference hardware system architecture group. If you're someone that works on security, we're working on that. If you want to work on instrument cluster, we're working on that. If you're working on virtualization, vehicle to cloud, containers, we're working on those. So my point is, we have something for you. So this is a call for you to get involved if you're interested in any of these topics and you're interested in the future software development for vehicles. Please get involved. We have something for you. And another development is that we're expanding. Let me back up. So one of the complaints we hear often is that it's hard for people to get hardware boards, reference boards that run AGL. AGL can run, for example, on a Raspberry Pi, and that's perfectly fine for some developments like app development. But sometimes you need an automotive board with, a CAN bus and automotive specific peripherals. And those boards are hard to get. You have to sometimes sign agreements, and some of the boards could be expensive. So what we've done is we've actually, some time ago, several years ago, created a reference hardware system architecture expert group. And the goal of this group was to produce a reference hardware board that could run AGL that is like a sandwich. And you can see the diagram here on the right. And that sandwich basically separates the peripherals, the automotive peripherals, the audio from the control board. And the control board contains the SoC chip. And the idea is that we can swap out the control board with a different one and a different SoC with very minimal impact on the software. All we need is a new BSP for the SoC and then compiling all of the drivers for the existing peripherals. And so we're happy to announce that the AGL reference boards are now available for purchase from Panasonic. The current chip is the Renesas R-Car SoC. But in the first half of 2022, we're actually planning to add a Qualcomm SoC, which Panasonic will provide and make available for sale. So if you're interested in any of this, you can check out the AGL Confluence page, which I've linked at the bottom here. And there's information on how to order this hardware from Panasonic and hopefully make for happy developers. But in addition to this, we're also expanding other options for the AGL community. This is work in progress. We're planning to support AGL on AWS Graviton. If you're not familiar, AWS Graviton is a cloud-based environment that is ARM 64-based architecture. It's perfectly, well positioned to run AGL. And we think this is a great option for development and testing. I think testing is one of the major use cases, in my opinion. You can spin up, the idea is that you can spin up an AGL instance a Graviton instance, and boot up AGL and start your development and testing work, all cloud-based without the need for physical hardware. And so we think this is a great opportunity to expand, some of the options for AGL community members to do their development. So if you're interested in this, stay tuned for more information, but you can also follow the expert groups that are working on this as well. Another development is, I mentioned earlier, Toyota is contributing their embedded automotive Flutter solution. So what is Flutter? Well, Flutter is an app development toolkit. If you're familiar with Qt, it's basically an alternative. And we will be supporting Flutter, and AGL will be evolving all of our existing reference apps to be supported on Flutter over the next year. This is very, very fresh off the presses. I believe the Flutter contributions have just come in from Toyota. So please stay tuned for more updates on this as next year goes by. And we hope to have this fully integrated in our future UCB releases. Another development is that has been proposed in the virtualization expert group. Panasonic is proposing to use Vert.io as a standard device interface for cloud native AGL applications. So why is that important? Well, it would really, eliminate some of the fragmentation that could occur between different platforms, meaning physical SoC-based platforms versus cloud native based platforms. So this is an interesting proposal that is just emerging now from the virtualization EG. And again, the goal is to kind of have an interchangeable AGL that can go from hardware-based SoCs to cloud-native environments with very little effort. So if you're interested in this kind of stuff, please follow the virtualization EG and get involved. So upcoming UCB releases, this is the fun part. As you know, we already announced that Magic Marlin will be released in February 2022. And as you probably know, my colleague Walt Miner is the gatekeeper and the one who creates these names. And I'm happy to announce, in case you have not heard, the next release after that will be Nifty Needlefish in July 2022 is the planned release date. And the next release after that is a mouthful. It will be Optimistic Octopus. And if you think that's too hard to pronounce, you can join Walt Miner's session and complain during his session. But I think it's pretty cool. Optimistic Octopus. Okay, let's talk about some of the AGL events that are upcoming or not upcoming in the case of CES. We decided that some months ago that we will not be attending CES 2022. We had secured a large booth in the middle of the automotive technology area. But when it came down to making the final payments and the commitments, we realized that many of our members, including members from Europe and from Japan that would normally participate in the booth with demos, would not be able to attend because of company policy and travel restrictions. We just thought that it was going to be a really big risk, and we didn't want to end up with an AGL booth that had basically only an AGL demo and no other members participating. We felt that that was not a good ROI, a good use of our time or funds, and so we decided to cancel. Having said that, we do plan to attend CES 2023, COVID permitting, knock on wood. And the booth selection will occur the first week of January, and we plan to select a booth at that time, and we hope to be able to get a booth in the same area. And in the months after that, we'll be announcing the call for participation. So for companies that want to participate in our booth in 2023, you'll be able to submit proposals. So stay tuned for that. We are optimistically planning to attend Embedded World 2022. We have a booth that is actually double the size of our previous booth that we last had in 2020. We are monitoring the COVID situation carefully in Germany. There is a possibility that Embedded World may move to June. That is up to them, the organization, but that's something I think that they're looking at. Meanwhile, we have invited members to submit proposals to participate in the booth. There is no cost to participate in the booth, other than you have to pay your own travel and you have to provide your own demo equipment. But everything else is provided by AGL. And for further information, you can find the CFP information at the bottom URL here on the events webpage of Linux Foundation. So in terms of AGL all member meetings, our plan was to hold an AMM in March in Berlin, but due to COVID, again, unfortunately, we don't think that will be possible. We think that, specifically, we have a lot of members from Japan, and some members from Europe have told us their company policy does not allow them to travel yet. And we're only a few months away, so we decided let's do something different. So we're going to do two things. We're going to hold another AGL Tech Day in March, so stay tuned for exact dates and announcements of that. It'll be the same format as last time, which is a curated set of speakers focused on AGL updates, focused on AGL expert groups. And then we also plan, again, COVID permitting, an AGL developer workshop in person in Berlin. So the plan would be, instead of a full-blown AMM, is to have just a single room, 30 to 40 developers, very technical focused topics. And this would be very similar to other developer workshops we've had in the past, for example, in Yokohama, Karlsruhe, and even in San Jose. So we're monitoring the COVID situation. This is planned for March. It would be planned for the week before Embedded World to limit travel so that the AGL staff and other people participating in both would not have to travel twice. And so stay tuned for that. We hope to be able to hold it. And in fact, one of the big OEMs is looking at whether they can host it in their facility. So we'll let you know if that's possible. In terms of future events, I've already mentioned our plan for March. The next event would be AMM in the summer, around the July timeframe. We're actually exploring Hawaii as a possible location. I'm sure a lot of people will be happy to hear that. If you recall, just before COVID hit, we were planning to hold our event in Hawaii because we felt it was convenient for people from Japan, fairly convenient for people from the US, quite difficult for people from the EU, obviously. But yeah, there's a lot of people that want to go back and try to hold an event in Hawaii again. So stay tuned for details on that. The next one after that will be ALS and OSS. This is already posted on the events site at Linux Foundation. This will be held in Yokohama. And again, we hope to have the ability to hold it in person, COVID permitting. Then we're planning to attend CES 2023, as I mentioned. And then the rest of the events for 2023 would be March and July would be Japan and Europe, as we normally do. And then for ALS and OSS, this is still to be determined. And stay tuned for those announcements. So in conclusion, I just want to say, as I mentioned, this is a great time to get involved in AGL. We're working on so many different things. We're seeing, as I mentioned before, we're seeing the consolidation of software. We're seeing, this blurring of IT, cloud, and embedded software all coming together. It's really an exciting time to be involved in automotive software. And so if you're interested in any of those topics that I've talked about today, please get involved. Go to our wiki, contact us, contact me, contact Walt Miner, our community manager, and we'll help you get involved. And it's really an exciting time. And speaking of which, I'd like to remind you that we will have an AGL detailed roadmap session. Walt Miner will be presenting that later today at 11:15 Japan time. Some of the interesting topics will be, how AGL is evolving from Qt to Flutter and Web App Manager, how we're evolving from the AGL application framework to Systemd, and how we're going to be moving from SMAC to SE Linux. These are all super interesting topics. Walt will be discussing these things in detail, as well as presenting a detailed technology roadmap. So please attend this session. And with that, I just want to remind everyone that, which I always tend to always do at the end of my presentations, that AGL is a code-first organization, and this will always be our mantra. We're here to produce code and to build software for the vehicle and address all of the software functions in the vehicle. And so with that, thank you very much for listening. I hope you have a great show, virtual show, and I certainly hope that we're going to be able to meet in person in 2022 at some point. Stay safe, everyone, and enjoy Automotive Linux Summit. Thank you.
Thank you, Dan, for the update for the great talk. Our next speaker is Hironobu Ishii. Ishii-san is a director in the Linux development division at Fujitsu. Since 2003, he has led the Linux development team to enable a variety of enterprise features and has supported mission-critical Linux systems for a variety of customers. He is now leading an open source development team, and his team contributes to a variety of open source software communities, such as the Linux kernel, QEMU, Linux Test Project, LTP, Kubernetes, Method 3, and more. Today, he will be discuss Fujitsu's focus on open source development. Please welcome Hironobu Ishii.
Hello, everyone. I'm glad to see you all here. I'm Hironobu Ishii. I'm the director in Linux development division at Fujitsu. Now, I'm leading the development team for Linux and container-related software such as Kubernetes. Today, I'm going to talk about Fujitsu's focus on open source development. But first, I'd like to share Fujitsu's purpose: to make the world more sustainable by building trust in society through innovation. This purpose was decided in last year, but I understand the word in red represents unchanging beliefs of Fujitsu. Then let me explain transition of Fujitsu's focus so far. In 2001, Fujitsu positioned the Linux as one of its enterprise OS and debuted in the community and started to enhance Linux. In 2010, Linux matured enough to be used in the trading system of the Tokyo Stock Exchange. Then Fujitsu expanded its focus to virtualization, software-defined infrastructure, container technologies, and ARM processor. Here are what Fujitsu contributed. I classify the functions we worked on according to the purpose. In a nutshell, Fujitsu has heavily invested in reliability, availability, and serviceability because they are critical to building trust between Fujitsu and its customer and between customers and their customers. I believe it is Fujitsu's culture. By the way, Fujitsu unveiled Fujitsu Uvance, a new global business brand delivering a transformation portfolio for a sustainable world. In creating Fujitsu Uvance, we imagine the world in 2030, which is a target year to achieve the United Nations SDGs. Fujitsu will continue to solve challenges currently faced by customers around the world. And now, with Fujitsu Uvance, we will also work to resolve social problems our customer will face in the future. The word Uvance embodies our concept of making all universal things move forward, advance in sustainable direction. Let me return to OSS. In the past, investment in OSS development at Fujitsu has been focused on the infrastructure and general purpose middleware layers from the software stack perspective. However, Fujitsu has been moving towards providing OSS solutions that focus on customer and social issues. For example, development activity in Hyperledger community is a good example. I understand this movement is consistent with Fujitsu Uvance. Let's look at example of Hyperledger Cactus. Cactus is a blockchain integration tool designed to allow users to securely integrate different blockchains. Blockchain is one of the key technologies for achieving the SDGs. This figure shows an example of car sharing service. In this example, blockchain that manages car usage rights and a blockchain that manages private coins can work together to create a blockchain-based car sharing service. So I can tell that we, Fujitsu, challenge with open source community to make the world more sustainable by building trust in society through innovation. And we are looking forward to working together with many of you in open source community. Finally, let me share Fujitsu's session information. If you're interested in, please join these sessions. Thank you very much for joining my session. Please enjoy Open Source Summit. Thank you. Bye.
Thank you very much, Ishii-san. Our next speaker is Kate Stewart, VP of Dependable Embedded Systems at the Linux Foundation. Kate is responsible for automated compliance tooling program and projects, including SPDX, Turn, Open Source Review Toolkit, and Fuzzology. Kate was one of the founders of SPDX and is currently the specification lead. Since joining the Linux Foundation, she has also launched projects like Real-Time Linux and Zephyr project. Today, Kate will be talking about the importance of engineering dependable embedded systems. So please welcome Kate Stewart.
おはようございます and good day and welcome. My name is Kate Stewart, and for those who don't know me, I've been at the Linux Foundation now for about 6 years, and I've been focusing most of my career in the embedded space. It's been over 35 years of working there and about the last 20 or so in open source. And what I'd like to talk to you a little bit about today is what we're going to be needing to do to look at trying to get dependability added into our embedded systems going forward. Now, just to refine the definitions, embedded software is pretty much software that is pervasive but may not have a human involved in it. There may not be a head on it, or it may not be being controlled directly by a human. There'll be machines interacting with it and so forth. We find these pretty much pervasive in our world these days, from anything in the cars to the telephones, robots, toys, home electronics, light bulbs. Embedded software is pretty much pervasive. And like all software, it's built on open source these days. And so we need to figure out how we can make it dependable, because some of these embedded applications start to interact with people in a way that could be, could harm people, or could have, consequences we really don't want. So this is, I think, one of the biggest challenges we've got. So embedded software, like I say, is pretty much everywhere, not just, automotive, medical, electronics. These are all things that interact with people, transportation, audio, and so forth. So the space here is huge. And a lot of the IoT world is based on embedded software. In fact, one of the things I was quite fascinated to find recently from this report, from a recent report, is that if you actually look, there's estimated to be about 10 billion devices, IoT devices out there right now. Well, there's only 7.8 billion people on this planet. So there's now more IoT devices on this planet than there are people. And if you look at the growth rate of what's being expected, you're going to see that it's expected to sort of will probably be twice as many in the next 3 or 4 years, twice as many devices than there are people. So they surround us, they interact with us. We need to figure out how we can make these things dependable so we can trust them. Especially when you start looking at some of these places where we're seeing security vulnerabilities. The medical space is obviously something that's interacting with our bodies directly. We want to know that it's secure. We also have energy management systems. We have cars, consumer electronics. All of these things interact with us, and they are vulnerable to security issues. And they are, there may be safety elements associated with them because they interact with people. So things are at risk. We need to figure out how we can reduce that risk. From the security angle, people have been waking up in the last couple of years. In 2020, Europe put out the guidelines for security for Internet of Things. At the end of 2020 as well, we saw the Internet IoT Security, Cybersecurity Improvement Act. All of these things start to help make things dependable and so we can trust them. But there's more than just security involved with dependability. Dependability actually has aspects of, is it reliable? Can it be maintained? Is it durable? Can it be threatened and still respond appropriately? Safety, is there hazards there that potentially engage there? And security. And a lot of this analysis you have to look at from a system perspective, not just a code perspective. Like just a single project. It's just all the projects being put together. We all know that open source is pretty much critical. Most of the code bases today are built on open source in Android and OSS. And there's applications have gone from having like 84 components to 528. Well, all of those are attack surfaces, potentially, if they're being used and interacted with, especially when you talk into the context of a full supply chain. So it's critical. We know from discussions and research we've been looking at over the last couple of years that 80 to 90% of software is written and maintained by external parties. Companies don't have the control that they used to have over the full software. They've got a lot more potential for time to market, fast innovation, features that people want. But we need to start to create a culture of secure coding and make sure it's backed up so that it's sustainable. We need to get this shift happening so that we can start to have the dependability we're going to need for our software going forward. Software is building blocks these days. As you saw, 528 components on average. And when we start looking at this infrastructure and all these components, they have to interact effectively with each other. And we have to be able to, to test them and depend on each component so the whole system can be dependable. And, that challenge is really important to us, as you see in medical devices, in automotive, industrial robotics. We want our open source components to be dependable. And when people have been creating them, these things have emerged from like hobbyist roots. Oh, I'm just making it available. Linux has been here for 30 years and it started off as just a project. And, it's evolved into a very good quality project. But we have to start figuring out how we can get more discipline throughout the entire open source ecosystem. And certainly the most common components, we know we have to be able to trust them. So where do we start to focus? Well, the first place to focus is going to be making sure we know all the pieces that are there. Having standardized ways of identifying the components that are making up a system, and being able to talk about the interactions between these components, who depends on what. The next thing is those common components that are the most critical. We need to, and our use across the most systems are obviously the first point to start to focus on, looking at the dependability of it. For looking at identification, we've seen a lot of evolution in this last year on improving the software bill of materials. There's been cybersecurity. So there's been an executive order from the Biden administration back earlier this year, and that's been looking at expecting it to be a software bill of materials. This is helping to shape the culture that people are starting to put software bill of materials into their workflows. And that will, I think, eventually help with the transparency, because it tells, what depends on what and what are the main relationships for these sorts of things. And in the last year, Software Package Data Exchange, or SPDX, has now become an ISO standard, thanks to all of the worldwide community that's been interested in creating SBOMs, as well as ensuring that we understand what's coming in from a licensing perspective, as well as now it can be used for security. OpenChain became an ISO standard in 2020, and it's all about handling bill of materials and having good processes in companies to work with this. These two are going to work together to help make sure that we actually have that transparency, so we can start to really assess what's there and we can work with it properly. Now, the SPDX is able to represent the embedded software. It can actually take and be able to look at it from a binary block. Like you've got your binary component. And if you want, when you're doing your builds, you can make sure it gets linked all the way back to individual source files or potentially even snippets. So having that full traceability is going to be key for detecting vulnerabilities and being able to remediate and understand whether or not you're impacted by a vulnerability, for that matter. It's also effective to understand that, okay, we have that clarity as to what's there, and we have that ability to understand all the interfaces. Now, the standard is freely available from ITTF's site, as well as we keep it up to date as it's evolving on GitHub. And anyone who's interested in making sure use cases they care about is represented in the next version is welcome to come join us on helping to evolve this standard. Now, the most used embedded components. Where do we want to be focusing? Well, obviously one of them is Linux. 69% of embedded systems are based on Linux, based on the survey that we spotted from 2019. I suspect it's even higher now. There's a variety of flavors of Linux that are out there. There's various distros. And people are using Linux as the core component on a tremendous number of IoT devices today. It's probably the dominant way that people are running OSs on embedded. So that's where we're starting to focus. There's been work that's emerged in a project called Kernel CI to improve the testing and the automation of the testing. The Linux kernel itself has a lot of very good quality metrics. Like I say, quality's been a focus for Linux kernel right from the start. And if you want to start involving features, you have to demonstrate to the other maintainers that you're improving the quality and you're making things better by including the code. So, and there's regressions, there's the LTSs, there's a lot of features there having things upstream is seen as the best practice. And this is one of the reasons that the Real-Time Linux project is looking at making sure that the preempt RT patches, which are very key for embedded, are upstream. So that's going to eventually help make real-time more dependable in the kernel. And then civil infrastructure project is looking at how can we support these software for 30 years, because a lot of these embedded applications have that type of life cycle. And so they've been slowly and surely looking at extending the LTS timelines and figuring out what they can do to harden some of these other components. The automotive grade Linux project, obviously it's looking for using, open source software in cars. We need to make sure that that's dependable. And so, they're very interested in these problems as well, and have been joining us in the ELISA project to make sure that we can start to articulate the safety in these spaces, which is a feature for dependability. And so the ELISA project, just to go into it, is trying to figure out how we can use Linux in these safety critical systems. We know we're going to need these types of OSs to interface with the hardware and run our software and algorithms, and run the sensors, run the gather the data, make effective and informed decisions, and so forth. And we have to start managing the risk there. So ELISA's mission is to work with the safety experts, work with the kernel experts, and work with system experts and figure out how we can have a common set of elements, processes, and tools that we can all be using. And so that when people start to design Linux into those systems, they understand how to do the analysis for safety. However, in the embedded space, sometimes Linux is just a bit too big. It doesn't get much smaller than 2 meg these days. And so in that sense, we've got projects like the Zephyr project, which is a kernel as well as a system around it. And it's taken a lot of its best practices from Linux. There's a Cell4 system, which is a kernel that they're looking at making sure that it's formally proven out. Zen and Acorn are hypervisor projects, so that you can start to segment things and understand the barriers and so forth. So there are other projects beyond Linux that are very key to the embedded space that we need to start focusing on. To go into Zephyr a little bit more, it's like Linux, it's got an LTS. It actually has its own security committee that meets has met from the start of the project every 2 weeks. And it is actually a CVE numbering authority with MITRE, and has a project security incident response team to deal with vulnerabilities and do vulnerability management. So best practices, making sure we can update things, are in Zephyr, as well as it's formed a safety committee. And it has it's a functional safety manager that the project has hired to help us manage putting the artifacts into place and structure the analysis. And it's going after 61508 certification directly. It's also collaborating with some of the other open source projects that I've mentioned on the last page on, okay, where can we get some of these open source tools and to put into the automation and the workflows, which I think will benefit everyone over time. So collaborating with other projects is something some of these projects are doing to get the tooling in place and infrastructure. It's got coding guidelines. We're trying to get that automatic checking and saying in, and it's got a maintainer hierarchy, so it's got responsibility for who is responsible for parts of the code. So there's people who care about certain parts, just like Linux does. But it is not Linux, and it is designed for the Ks of memory size, as opposed to the megs of memory size. And one of the things that's key here is you only build into an image. For Zephyr, what you actually need is kconfig like we have with the kernel, but and you also have the ability to generate an SBOM automatically on build to track it back up to the source file level from the binaries to the sources. So it's been trying to follow whatever it's found as best practices for the last 5 years. And it's one of the few projects that's got the CI best practices gold badge. The CI best practices gold badge is one of the programs in the OpenSSF, or Open Source Security Foundation. And it is looking at what are known best practices and then having publicly documenting them and exposing that so that others can follow and others can extend. Now, the system isn't just one project. it's a set of projects. And so the Octo project has been focusing on how they can pull information together and improve the quality. I've just mentioned the OpenSSF, Open Source Security Foundation, which is focusing on these things. It's also focusing on identifying the critical components. And they've got various scorecards about criticality. They've got the CI best practices badge. They're looking at putting out free training so that people get educated on security best practices. So there are groups in there that are focusing on this identification problem and how we can improve things. The Chaos project has been working on risk metrics and coming up with standard ways of measuring risk and being able to assess project health and look at the risks associated with using an open source project. All these are factors that we're going to need to understand whether software is dependable or not. And to look at, Yocto's dependability story, it's got reproducible builds. So it's been working very hard to put this in play, and it's there in the latest releases. And it's been pretty proactive about adopting security best practices with this. You're able to minimize what you're actually put into an image for a system, which obviously minimizes your threat surface. You can have it just what you can configure it to be just what you need. And it also has added in the last year automatic software bill of materials generations with SPDX. So you can actually get an articulation of all the components you've got in your stack and be able to have that traceability. It's had introduced long-term support releases as well. So you have one part that's there and supported for an extended period of time, and bug fixes are put back into it. And there's also commercial support available for Yocto. We see many commercial organizations supporting it at this point in time, and it's got a variety of update mechanisms. And then we're also seeing Yocto starting to be having groups in certain verticals like automotive and automotive grade Linux collaborating around best practices and having common infrastructure there. So we're sort of starting to see this part of the dependability story emerge nicely. So a couple final thoughts. Embedded systems use open source projects. It's a reality, and we need to get the upstream projects to be dependable. There is standardized software components out there. We need to figure out in a standard way of how to communicate this information, and we need to make that SBOM generation automatically part of any build we do, and any import we do, or any export from one company to another. The software supply chain, we need to start making it explicit. And whenever you put a binary out, expect an SBOM, I think is what we're going to need to get to. And then figuring out which projects we all should be focusing on and helping to improve. My most widely used projects, I've listed a few of them, are some of the ones that are key for embedded. But there's probably a lot more out there. And I think as we do more analysis of the ecosystem, we start to see the transparency emerge. We'll understand more of these critical points to focus on. And then I think the last thing is, the software engineering practices have not always been applied to open source projects effectively. And so getting the best practices more visible and adopted is some of the things we'll be trying to do in the next few years. So this is not going to be solved quickly, but I do think if we all work together, it can be. So with that, I'll say thank you. And if you've got any questions, please don't hesitate to reach out.
Thank you, Kate. Our next speaker is Brian Behlendorf, General Manager of Open Source Security Foundation. Prior to this, he was the General Manager for blockchain, healthcare, and identity at the Linux Foundation. Brian has a long history with open source software, going back to co-hosting the Apache Web Server project in 1995. And from that point forward, founding or working for a series of companies, nonprofits, and governments in his role. Today, Brian will discuss how OpenSSF is securing the open source supply chain. So please welcome Brian Behlendorf.
Konnichiwa. Hello, and thank you for coming to my talk. I am Brian Behlendorf. I am General Manager of the Open Source Security Foundation. This is a relatively new part of the Linux Foundation. We've been around for just over a year, and I've jumped in to help over the last few months as General Manager. And I can't wait to tell you all about what we're doing at the Open Source Security Foundation. We're really focused on securing the open source software supply chain, and we need all of your help to be able to do that. We're really here to serve the interests of the entire open source community. And so, and it's only going to work if all of the different projects at the Linux Foundation and beyond work together to make this happen. So let me tell you about all the things we're doing, and hopefully you can join us and look for ways to incorporate what we're doing into your projects. So it's pretty easy to make the case that the open source software explosion is creating a lot of value, but is also creating a lot of challenges for the industry. There are over 40 million different open source software components available. And that might seem like a high number, but think about all the GitHub repositories out there. Think about how many releases the average repository makes. Think about all the people who do a fork of that repository and create their own version. And I think you'll pretty quickly realize there's a whole lot of components out there people are putting together when they build software. And this is only going to get worse. Over the next couple of years, it's expected that the number of components will grow by an order of magnitude to 420 million different components. And of course, that number is dwarfed by the number of downloads that we see of software out there. Over 2 trillion distributions of software taking place from major repositories, from GitHub, but from everywhere that you get software from. And a lot of this software is open source software. In fact, by our reckoning, 90% of the average software stack of the modern application code is based on open source software, or simply is open source software, with just 10% of the average proprietary software package or deployed image being proprietary code. But we have a problem here, which is not all of this 90% of the code is perfect, right? Software never is perfect. It's never finished. There's always bugs waiting to be discovered. But there's an awful lot of software distributed with known vulnerabilities. In fact, 29% of popular projects by one measure by a company called Sonatype contain known vulnerabilities. A software where, whether it's the included dependencies or even the core code itself, where there's known vulnerabilities that have not yet been fixed or dependencies updated or that sort of thing. And even amongst the non-popular projects, there's a very long tail here. And by their measure, 6.5% of those contain known vulnerabilities in them. So this is a problem at both ends of the scale for the software industry. And really the way we've taken a look at this is thinking about the software supply chain. Thinking about this very much like you might look at diamonds or bags of rice or any other type of good that moves from source to destination. Software too moves from something that exists in a developer's head or a group of developers as they work on code through to its IDE, into a source code repository, into a build system, and then combined with other packages into a package distribution mechanism before it's ultimately pushed to the cloud or as an app to a consumer. And of course, there's a cycle there where dependencies incorporate this as well. And at many points in this chain, in fact, this is a graphic that one of our working groups came up with. There's at least 8 different places where we kind of take things for granted as software developers, where we assume certain things about the world that might not actually be true. For example, we might assume that source code always gets well vetted on its way from a pull request into the source code repository itself. But a whole lot of projects will sometimes accept code without necessarily reviewing it or knowing what to look for when it comes to enhanced security. Software also can bypass controls in the source code control system. We've seen many compromises where Git itself or Subversion or others get compromised behind the scenes without any of the developers realizing it until it's too late. We see modified code as it comes out of a source code control system and makes its way to a build platform. It could be that the build platform itself is compromised. And then every time we build software, we incorporate dependencies, right? And how do we know which dependencies we've really pulled in? There are often cases where private dependencies get pulled in by companies out of their own local repositories, but then somebody has created a package with the same name in a global repository, and that has come in and supplanted the more local one, and perhaps that one has a hole. There's some well-known attacks that have happened because of that. Finally, as you're going through the build system, through the CI/CD system, sometimes the kinds of checks that tend to happen there can be bypassed. And then even when it sits in a repository, the package repository itself may be compromised. And as the end user, you fetched a package off of a server somewhere. How are you really certain that you're getting what ultimately the original developer intended you to get? How do you know you're not getting something that's been compromised on its way down to you? It's not good enough just to know you're getting it over a TLS connection. The package itself might have been modified before being sent down the pipe, down to you or down to your cloud. So all these different things represent systematic issues. This is not anything that's going to be solved with one piece of software, with just everybody waking up one morning and deciding to be secure. These are challenges that are going to require thinking systematically about how the open source community builds software, how we tag it, how we use metadata, how we think about credentials, how we think about levels of attestation, and all of that incorporated into creating products at the end that consumers can have a higher degree of trust in. This is our challenge. And we see today that the software supply chain itself is increasingly a source of attacks. Over the last few years, those breaches attributed to supply chain breaches, such as the SolarWinds hack, are increasingly being seen as supply chain breaches, not just vulnerability in code. So often, the vulnerabilities have been fixed and simply not adopted by downstream packages. So often, people assume their build systems are uncompromised, right? And that can lead to really unexpected situations. So what can we do about this? Well, the Open Source Security Foundation was formed as a cross-industry collaboration, bringing together leaders across the open source industry to improve the security of open source code by building an expert community, having a set of targeted initiatives focused on supply chain security, and really emphasizing the importance of best practices. We serve as the cross-industry focal point for securing investment, resources, and expertise in improving open source software supply chain security for everybody. We do this through a number of different approaches. The typical Linux Foundation project is really just focused on shipping code for things like the cloud or for blockchain technology or the kernel itself. We're focusing on at a different level. So the first step is identifying what are really the most secure, what are the most critical projects out there in the open source world. What are the ones that represent that tiny little block that if it happens to have a weakness, everything else falls down around, right? And we do this by looking at audits, looking at talking to teams, thinking about talking to researchers, but also thinking about the package management systems and tool chains and the like, and then thinking about which ones should be audited, which ones should perhaps be enhanced with response teams, which ones might it be worth funding actual improvements to in order to help harden the rest of the open source ecosystem. And that's really where we get into fixing things. So what if we could create an ecosystem where the time to fix a vulnerability and deploy it across the ecosystem is measured in minutes rather than months, right? What if we could really create a whole lot of incentives for people to adopt those fixes or to fix the vulnerabilities that are lower priority than adding new features or the like? So here we're really looking at how does the vulnerability reporting process taking place? How does coordinated disclosure work? What are the data formats that are used in those vulnerability notices? And are there ways that we can improve how that works specifically for the open source community, specifically for the fact that you so often deal with volunteer teams who are overstretched in how they work? And one way that you do that is through automation. So there's a whole lot of security tools out there for scanning source code, for performing audits, that kind of thing. We're not interested interested in building those. What we are interested in doing, though, is saying, how do we get the outputs from those kinds of tools into an environment where open source developers can, sort out the false positives and bring the aggregate reports together and understand, what are the pieces that I really should fix? What is high risk versus what is something that's already been dealt with or isn't really the kind of problem that the tooling thinks that it is. So there's a whole lot of room here to build software that actually does improve that, but build it as more of a portal, more as a service to the world. And this is something the Linux Foundation has been investing in for a couple of years now, actually. Once we've identified those, how do we build relationships with the relevant stakeholders in the open source community, with the projects that are behind the major open source packages, all of and help them understand the security posture that their projects have and the proper processes that they should follow, and really work with them and listen to them and understand how they work, so that we can really seek to harmonize this across the open source ecosystem. And of course, understanding how to build that kind of code, is an art form, right? There's a skill to it, but it's also really important that this be something that all open source developers really understand the difference between writing secure code and code that is easily compromisable. And so developing content, developing training modules, certifications in this space, all of that is really important, a really important part of what we'll do. And then finally, there's a lot of work to do in establishing standards for how to sign packages, standards for and how digital identity can work in a supply chain, standards for levels of attestation. That's something called the SALSA effort, which you'll hear more about in a bit, for standards for identifying, tracking, tracing, and updating security, license, and architectural metadata for software supply chain artifacts. Some of the things we've already accomplished in OpenSSL in the first year, OpenSSF, sorry, we've created a set of courses called the Secure Software Development Fundamentals. These are 3 free courses available on edX today, and over 5,000 people have taken that course. There's a very simple registration process if you're interested in doing this. We've also, another group has created within OpenSSF, created something called a scorecard, which is an automated, the security scorecard, an automated analysis of project security mechanisms. How quickly do projects respond to security notices? Do they have a security mailing list? This is really the next step beyond the CII best practices badge that many of you are familiar with, which we've also transitioned over to OpenSSF and created additional criteria for those 4,000 participating projects in that system. We've also drafted a guide to coordinated vulnerability disclosure for open source projects, which we're really excited about. This is something that will help up-level every open source community, every group of maintainers on how they respond to vulnerabilities in critical software. We've created a draft called the Supply Chain Levels for Software Artifacts, also known as SALSA, which are criteria for improved supply chain integrity. We worked with Harvard to create a survey of open source developers around their approaches to security, which we've published. And we're in the midst right now of distributing, before the end of this year, 1,000 multi-factor authentication hardware tokens for developers to use as they're writing code to help enhance the integrity of the software that they're building. And we're distributing those to critical open source projects in a very direct way. And these kinds of accomplishments come from the primary motion inside the organization, which is a set of working groups focused on best practices in software development, in secure software development, in vulnerability disclosure, as I've mentioned, in identifying security threats, like what is your threat model? What are the kinds of attacks that happen out there? And can we boil those down into scans, into metrics, into the kinds of things that really help us get a radar across the open source ecosystem and in terms of what's secure and what's not. Identifying those critical projects that need help and then going out and actually helping them is one of our big keys as well. We have a security tooling working group as well, asking what are places where we can make changes in the standard software development tools that are available, particularly those focused on security, but to make this easy for developers to adopt, right? Perhaps it's changes in the tool chain. Perhaps it's changes in, products like GitLab and GitHub, and in the package management tooling out there. These are all things that working group is really focused on. And then the digital identity attestation working group is really looking at that whole software supply chain, and going, what are the places where we can raise the floor on how software makes its way from source to destination. And then we're just getting started on a set of special initiatives. One in particular I want to point out that all of you can go to today is something called Project SigStore, which is a software signing tool. It's a tool for issuing certificates to software developers to use to sign releases and sign artifacts. Very much like Let's Encrypt, it's based on users' email addresses and the security proof that you own an email address. And so it's an ephemeral, meaning short-lived set of keys to use to sign those releases, just to help ensure that what gets to the endpoint is actually maps to what was built by the software team upstream. And all these projects work together across that map of the software supply chain in many different ways. And I won't go into too much depth here, just to show you there's a lot of different activity. We're working hard to provide a consistent picture to really say each of these tools are the best of breed, and really represent the best of all possible efforts that can come together to make this work. And I really want to emphasize, this is not just some academic kind of conceptual, hey, wouldn't it be great if the world adopted these new standards we're coming up with? That would be like boiling the ocean, as they say. Instead, what's really important about OpenSSF is we've pulled together all the key technology companies involved in the software ecosystem. I mean, there's so many companies that write software, of course, but when you think about how does software get built? What are the tools that I use to build it, right? What do I use to debug it? What do I use to publish it, and the channels to get it out? You're going to be thinking about these kinds of companies, all of whom have joined as premier members of OpenSSF. And it's really been key to have them involved. You might also see as well companies in here who are large consumers of software and operate in regulated industries and very security sensitive industries. The financial services partners we have, for example, who have in many cases more software developers than most of the other companies in the world, right? But they care increasingly about, because they're huge users of open source code, increasingly about being able to make smart choices when it comes to consuming open source, and smart choices about how to contribute back upstream and encourage a better security profile by default. We've pulled together an amazing set of both premier and general members supporting what we're doing, and it wouldn't be possible without their involvement. Everything we do is public facing. Every initiative that I've mentioned has a Slack channel and a mailing list and a GitHub repo and all the other kinds of public-facing engagement vehicles that you expect from a Linux Foundation project or from any well-run open source project. But it's these organizations that really contribute at a level that we're really grateful for, and help financially support the organization as well. So we would love to have you involved, no matter what role you have today in the open source ecosystem, whether you are a developer writing code or simply using open source software and you want to learn what are some practices that you could follow to make smarter choices about what software to adopt for yourself and for your organization, right? There's really a growing recognition out there that collective change requires collective participation to help drive the security of software. This is not a problem any one of us is going to solve on our own. This is not just going to be resolved by the cloud native community or the Linux kernel community. This is something all of us have to work together to make happen. And this is a place where companies can really play a leadership role in this, or a place where organizations can say, we use open source software, we publish open source software. It's important to everybody in our own industry to do this in a secure way. And this is something that you can tell your stakeholders about, and we think will be important. And finally, while our bread and butter is technical contributions and content contributions, so much of the kinds of things we have to do take some real resources. We've been fortunate to raise a substantial amount of money money from our major partners to help us in that mission, but we can always use more. We can always use more impact when it comes to getting the word out, to launching new initiatives, to funding fixes in open source code. We'll have quite a few opportunities to support both the core of what we do and special initiatives on the periphery that we would love all of you to come and learn more about. So with that, I really encourage you to come to the openssf.org website to learn more about what we're doing, to consider joining the initiative, either as an individual, joining the different working groups and learning more about the different activities going on, or to join as an organization. We really would love to expand, especially in Asia, the participation of the Linux Foundation members there and more. So, arigato gozaimasu, and have a really great day. Thanks.
Thank you, Brian. We now have a break before conference session begins at 11:15 in Japan Standard Time. So grab some coffee or a snack, then join one of the breakout sessions. Don't forget to visit our sponsor booth throughout the day. And also, we have some great event experiences, including social media wall, the Zen Zone, our virtual swag bag, and games. So be sure to check them out as well. And also, if you run into any technical issues today, please reach out to the help desk channel on Slack or in the lobby chat on the event platform. And finally, please have a fantastic day.